Hi, I really wanted to put together a video as kind of um, a review of all the functions that we've learned this year. So I'm going to actually just title this Algebra 1 Review. Now, I hope that you watch this video more than once. It is something that will help you, hopefully before you take your EOC. If you can master this video and you feel comfortable with all the topics in this video, then I have no worry in the world that you will be just fine on your EOC. So saying that, within the context of Algebra 1, what we have learned, everything stems off of this. Everything is a function. Okay, everything is a function. Now, if you remember what a function means that the x values cannot repeat. So in that case, that means that it passes the vertical line test. So, and you can put that beside function if that helps you remember what a function is. It passes the vertical line test. The x values cannot repeat. Something else within functions is the concept of f of x, that is called function notation. Okay. So within function notation, you should be able to feel confident in saying that f of x is -2 and your function is 3x plus 2, then you're going to plug in -2 for x, or every time that x occurs, and then solve for what f of -2 is. Okay, it's the idea that f of x is equal to y. Like in your calculators, you have f1 of x, f2 of x. That means that you're adding more functions into the calculator. So within this idea of function, we have covered 3 functions in Algebra 1. We have covered 3 of them. We have covered some more, a little bit more time than others. The first one that we're going to talk about is the linear function, which, if you remember correctly, that means that it forms a line. Now, within linear functions, there are 3 different forms that you have. You have y equals mx plus b, which is your slope-intercept form. You have ax plus by equals c, which is your standard form. And then you have y minus y of 1 equals m times x minus x of 1. And that is your point slope. You will have all of these on your reference chart of your EOC. So I'm not too worried about whether you can memorize them or not, because they are given to you. Now, within this linear function, you were asked to find domain and range. That is where you're finding the x values, where the function occurs within the x values, where the function occurs in the y values. Remember to always start from negative to positive, both ways. That can be within domain and range. You've got interval notation, and you also have using inequalities. We've done this many times. Hopefully you feel confident in that. And then you also have parallel and perpendicular lines. I want us to also look at the graph. Okay. When you're looking at the graph, now I'm going to graph just like that. Oh, it would help if you could see that. Sorry. When you're looking at the graph, it is going to form a line. And it's going to go on forever. Now, there are restraints on that, and you know that sometimes in real life situations that you can't have a negative distance or you can't have negative time. So that's something to consider whenever you're looking at real life situations. Now, I also want us to look at the function. What does it look like? You could see it in two different ways. You could see it as f of x equals x. You could see it as, or you could see it as y equals x. That's your function notation that we did up here. So you've got f of x equals x, and that's your parent function, y equals x. Okay, and then you, of course, can have it in these three different forms also. Now, the next thing I want us to talk about is a table. Now, it's an input-output table. So basically, it is a working function, has an input-output of x. You can either see, I'm going to leave it as f of x. So when you're doing this, and if you do not know what it looks like, you can always create an input-output table. So just create some x values and you can plug it in. Well, if you're plugging it into this one, we've got y equals, that's 0. Y is also going to equal 0. Y is going to also equal 1. Y is also going to equal 2. Now, and so forth. So whenever you're doing that, just be aware, like if you were only given a table, could you create a function? If you can't, you can always put it in, like I taught you a couple days ago, to put it in your calculator, and it can give you the regression, which will, I mean, hopefully you can do it without doing the regression, but if that's what you feel comfortable with, absolutely do that. That's a great test-taking strategy. Now, I really didn't want this video to be longer than 5 minutes, but you see I'm going over 8. So I'm going to try to make the rest of this a little bit quicker. The next function is a quadratic. Within a quadratic function, we have two different forms. We've got f of x equals ax squared plus bx plus c, which is your standard form, which this is in your polynomial form. And then this is your vertex form. This is the form that you want it in when you want a graph, as in vertex form. So you can easily see where the vertex is, where the axis of symmetry is. I feel like y'all do a really good job of doing the key attributes, which I'm very proud of. I think you've done a great job with that. Within quadratics, you are also required to know domain and range, which we've discovered that in domain and range, for every quadratic that doesn't have any set boundaries, will be all real numbers, or negative infinity to positive infinity. Your range is your y values, and you know that there's going to be some kind of, it's going to stop at your max or your min. Within this, you were asked to find the solutions. And we know that there are 4 different words for solutions. Solutions: x-intercepts, zeros, and roots. So you should be able to know all of those as your solutions, where it crosses the x-axis, where the function crosses the x-axis. Okay, now this is going to be your graph. I'm going to go ahead and plot a vertex. Okay, again, hopefully you can get if you can see it. And then in this, you've got the point 2, -3. And then that function, what is that function? Well, the function, whenever it is in vertex form, is, pretty simple as far as you might not know what the a value is, but you can always solve for that. Pick another point and then solve for a. Or you can always graph it on your calculator and see, use your best judgment. And that's one thing I want you to do is when you're in a situation where you're testing. I'm not there, so make sure that you can keep going. Like, use your strategies. Use some multiple choice questions. Just use all your technology that you have. I mean, that calculator is so amazing. So just please be aware of what you can and can't do with that. And if you don't feel comfortable using it, please come ask me. I'll be more than happy to sit down with you and help you find some things that you don't feel comfortable with. So I'm going over 12 minutes. I'm sorry. What we're looking at here is the vertex. So remember it's going to be opposite day inside the parentheses when you're dealing with quadratics. And then you've got -3. Okay, and with this table, you could also create a table whenever you're doing this. It's another strategy that you can use. You can pick some points, and we've done this a couple of times. What you're doing is you're just plugging this in, and that ends up being -2, -3, and then -2. So you're able to plot those points. So at 1, -2, I did a really bad job of drawing this, obviously. So at 1, -2, so it'll be right here. And then you've also got 3, -2. Not too bad, but so that's one way that it can guide you in graphing your points. The last function, hopefully I can finish within 15 minutes, is exponentials. Okay. Within exponential, there is only one function. It is f of x equals a times b raised to the x power. So within this is our March Madness problem. We will do some more practice with this over exponentials, but I feel like with the March Madness problem, it's very easy to helps you formulate an idea of where could I use this in real life. So within the exponential functions, you are required to know, I hope you're seeing a pattern here, domain and range. And then also you're asked to know growth and decay. Now we've talked about this in the context of the March Madness problem, but we're also going to start doing some growth and decay word problems. That will be what is on your EOC is growth and decay in word problem form, which once you do a couple of them, you kind of start to see a pattern, and then you're able to formulate those equations pretty quickly. So let's look at the graph of this. We've got our point right here. Okay, so this actually is the function y equals 2 raised to the x power. Or you could also see it as f of x equals 2 to the x power, and same thing here, f f of x equals x minus 2 squared minus 3. Okay, and then our table, our handy dandy table. It always helps to create a table if you don't know what it looks like. So we can just pick some points. We can pick 0, 1, and 2. We got, now you plug in 0 for x. Anything raised to the 0 power is 1, and then 1 raised, or 2 raised to the first power is obviously 2, and then 2 raised to the second power is 4. So I hope this helps. I went over 15 minutes. I didn't want to do that, but I really just wanted to encompass all the functions that we've learned this year. I hope that you watch this video more than once, not necessarily within the same time frame, but maybe right before the EOC the night before, go back, watch this video. It is a great, I hope this is a great tool for you to help you study, and I feel like you're going to do wonderful. I really just wanted to give you a conclusion of the functions that we've learned so far. So I hope this helps. Thanks.